Hello everyone. Today I'm gonna talk about a problem which is called hundred fowls problem. So one of the example of the hundred fowls problem is this. If 100 bushels of corn be distributed among the 100 people in such manner that each man receives 3 bushel, each woman 2, and each child half bushel, then how many men, women, and children were there? And I have taken this problem from 8th century. Yeah, this problem has a long history. One of the manuscript found in Pakistan in 1881 called Bakhshali manuscript has this problem also, and the manuscript is dated back to the 3rd century, so we can say this problem has a long history. So today I'm going to show you like how to solve this kind of problem. The one thing I would try with this problem is just a random guess. Like for example, let's say my guess, I would guess like 32 men and 42 women, and then I need obviously less than 98 children, right? So let's guess number of men is 20, number of women is just 10, and then children is 70, because we have 100 bushel of corn and then we need to distribute that to the 100 people. So we want to make everything 100. So 20 men, 10 women, and 70 children. And then if you do the 3 bushels for each man, 20 times 3, 2 bushels for each woman, that's 20, 10 times 2, and then the half bushel for the children, then you have that. If you add all together, you're gonna get 115, and which is little off by 15 because we need that to be 100. So we can really manipulate some numbers and then try and try and try. We need to try kind of more. But one of the solution I got like after some brainstorming is 5 men, so that gives the 5 times 3, 15 bushel of corn, 25 women, 25 times 2, it's 50 bushel of corn, and then 70 children, that's 35, because you want to multiply 70 times half, and that's going to give 35, and altogether 15, 30, and 35 makes 100 bushel of corn. And this also makes 100, 70, 75, and 25, that's exactly 100. So 100 people, 100 bushel of corn. So that's one solution, and there could be more solution than this. So to see that, I think the best way to do is to use algebra. So we will have 2 equations and 3 unknowns. So it looks like the problem is kind of unsolvable, but it is solvable. So we have 2 equations, so man, woman, and children equals to 100, and if you give 3 bushel to man, 2 bushel to woman, and half bushel to children, then that's gonna equal to 100 bushels. So from that information we only have 2 equations here. So in general we need 3 equations to solve this and they solve the problem with 3 unknowns, but we need to do a little trick on this to be able to solve this equation. So let's see how we want to do it. So we want to multiply 1 by 2, equation 1 by 2, that's gonna give it twice, 2w 2c equals to 200. My idea is to cancel, get rid of 2w, and then I want to subtract that from this equation from 2, so that way I would get, I want to subtract this guy from this, so I'm subtracting 2 from 3, 3 from 2, I'm sorry. So when I do that, then I would get 3m minus 2m is just m, and then this is just gone, 2w, and then I have 1 half, and then 2c, so 3 half c negative, and I have negative 100 there. So when I do the little calculation, like I just add plus 3 half c on right side. So now the trick comes here, because the solution cannot be the other than the whole number. So if you want to get this m, that means number of man, and the whole number, then you need to make sure that when you choose this value, I'm basically going to choose the random number for children. So but I cannot choose any odd number, because if I do that, then that's gonna limit this in the fractional form, and it's gonna go to the decimal form. That doesn't make sense if we get that. And then when I choose this value, I don't want to make it more than 100. The whole thing, I don't want to make it more than 100, because that's gonna give you I want to make it more than 100, otherwise I will have the negative solution. So to make more than 100, so I have to choose at least, say, like 33. No, 33 times 66. If I do 66, then that's gonna cancel. If I choose 66, then that's cancel, give 33, and that's gonna give you 99, and minus 100, so that's the minus 1. So I need to start with at least 68. So I start with 68. Okay, so if I start with 68, then I cancel that. That's gonna give me 34. 34 times 3 is 102, and that's gonna give you 102 minus 100. That's gonna give you man equals to 2. So we choose children 68, man 2. Now the woman need to be 30, right? Because that's 68 plus 2 is 70, and woman 30. And if you wanna see if that number really works, then you can again do the 68 times half. That's gonna give you 34. M times 3, 2 times 3, that's gonna give you 6. 34 and 6 is 40, and then the woman 30, it gets 2, so 60. So 60 and 40 is exactly 100, right? And then you have other solution too. When you try all those numbers, that's gonna work. You can increase the number of children here, and when you increase the number of children 70, then you're gonna get number of men 5 and women 25. So these are all other set of solutions. So 1, 2, 3, 4, and then the one we have. So one we have over here is the 5. So we have altogether 5 solutions for this problem.